completed the 5-axis routines on here, and now we're going to go to a 3-axis machine to finish off our operations. So here we go. This is what our stock should look like at the moment. And we're going to take this and we're going to put it in a traditional vise in a 3-axis mill. We want to clamp it about halfway across these holes because all the work we're going to do from the orientation we're looking at the part at right now will need clearance for the cutters to roll over. I'm going to go ahead and minimize this, and we're going to do a little investigation here. So if we can carry over from this stock, we're going to be basically milling the hat off and the edges of the part. So we're going to go to setup. So we're going to right click and we're going to create a new setup. Now we're going to get some warnings off first, and that's okay. Now because we're clamping on the hacks, we want to set up our origin based off what we're clamping onto. It's qualified surfaces on the octagon. So we clamp against this forward face, the opposite face, and the left hand side can be our datum for our stop. Okay, and we're going to switch here to model box point, but at the moment we have the stock volume shown, so we're going to hide that, and then we're going to go to model origin. It's going to be we're going to pick plane normal to the z-axis and then the x-axis. So we pick the top of our part and the front edge, which is in the x-axis direction, and this should set the origin in the direction we want. Now instead of basing it off stock, like I said, we're going to go off model box point. And it looks like our model is not selected, so I'm going to go and pick the model itself, so that when I go to model box point, it's actually the model itself. So this isn't always by default selected. Make sure you've got your body that's the actual part design selected so that you can pick this back left corner. Now the reason I'm choosing the bottom of the part, we've already qualified that surface. That's what's going to be touching our fixtures. And to set this, we'll put the part on top of parallels, but to find the origin on top of that parallel, we'll use a 1, 2, 3 block clamp so that the one direction is in the z-axis, and that we set our origin on the corner of that to a stop and to the top surface, and then when we go into the offset menu we need to compensate by a -1 inch to lower that origin to the top of the parallels. The reason we do that is we don't want the cumulative error of the fixturing where we held onto the part to influence this. Okay, next tab, our stock. We'll leave it from previous operations, see if that works for us. We do want to deselect the Haas VF2. That was, if it's still selected here, that was an error in my judgment when we set up the part originally. Okay, and then we're going to go to post-process. We're going to call this 7303. We're going to call it op 3 because the first op would be our stock op that makes the dovetail. And we're going to use the first coordinate system, which would be G54, available on the Haas. Okay, and we'll hit OK on that operation. And then we're going to rename this op 3 to be consistent. We can actually steal the routine from our op 2. We're going to grab our face mill, and we're going to right click on that and hit copy. We're going to come back to operation 3, right click and paste. We're going to right click on the routine and we're going to change some things. We're going to leave all the motions at default. Under geometry though, we don't have a tool orientation. We're going to deselect that, which will bring on our setup orientation for 3-axis. And you notice it flipped to the top, and we got our orange rectangle, which is the volume of what we're machining. We'll then go to heights, and our top height will be stock, and our feed height will also come from stock. Our bottom height will be the model top. So we're going to be machining between the two blue planes. Now what we're machining off is the height of our dovetail there. And that works out to about 344 thousandths when you do the math. So we don't want to do that all in one pass with this cutter, or we'll break it. So we're going to leave all this at default, but we're going to check this box called multiple depths, and we're going to take 60 thousandths off per pass, which I believe is the maximum for this cutter. And we're going to use even step downs, and we're going to add a finishing step at the end, and we're going to go 30 thousandths finish, and we're going to slow our feed rate down to 100 inches a minute. In retrospect, we're going way too fast for how small this is. So let's go back here and let's slow this down. Let's go 100 inches a minute on these instead of 280. And our finished feed rate will be 50. All right, in our last tab, we're going to leave everything at default. We just want to make sure this vertical lead in is at 0. Is that okay? And we should get several passes. Alright, now we can do the same thing with our next routine, which is going to cut this pocket. We're going to go back to Op 2 and we're going to borrow it. We're going to do a copy, close it back up, go to Op 3, we're going to paste. We're going to right click, we're going to edit that routine. We're going to leave everything at default on the first tab. On the second tab, we want to deselect what we have selected, and we want to unselect the tool orientation tab. And then we will select our new pocket and make sure that the Z-axis orientation is pointed up. On our heights, we're going to go from model top to model top because we've already machined off all the material above that. And our depth is going to be the selected contour. That's fine. Next tabs, we can leave all this the same. Next tab left alone, and the last tab should be the same as well. And hit OK, and we've now pocketed the inside out. Okay, next operation is going to be the inside fillet here. We're going to use a command called spiral. Okay, and what this does is it spirals in a circular shape down the surface. And we're going to use the same step over we used in the 5-axis, and we'll see if we see a finished difference between the two different sides. So we select spiral. We're going to use our 1/8 inch ball mill from our library. And we're going to bump the RPM up to 6,000 and 60 inches a minute. And we're going to go based off selection, and we're going to select the top circle and the bottom circle of the fillet. We're going to change our tool containment to outside the boundary because we want the ball cutter to go past tangency on the interior. And it's going to ask you to select a center point. So we're going to select the center of a circle that's concentric to what we're moving in. So we'll pick the bottom of the pocket. And then we're going to avoid surfaces. Pick the top of the part, so we're going to avoid that by 4/10. And on the bottom, we're going to do something different. We're going to hit we're going to control that with the heights tab. Again, we're going to go from the top of the model, not the stock, in both cases. That lowers our planes down. And we're going to select where we want the lowest of our cut to go. We don't want it to go to the bottom of the model. So we're going to pick the floor of this pocket, and then we're going to add 5 thousandths clearance on the bottom. That way we don't gouge into it with that ball cutter. Should be fine. Now we go to the next tab, is passes. And we are going to machine from the outside in. And it should be going counterclockwise. We may have to check this box. It's kind of confusing on how it interprets what way is clockwise. So we'll have to simulate it and see, make sure it's climb cutting. Okay, we're going to leave the outer limit at default, and our step over is going to be 5 thousandths. We want to cut in one direction, so one way, and we're going to go, we can go both up and down. And then we're going to pick this box that says smoothing. That's just going to increase the tolerance at what the surface is cut at. Multi-axis, there's nothing to set on that tab. And then we've got our linking, which the only thing we want to get rid of is that vertical lead-in radius. We want that to be 0. And on the other end, 0 as well. Alright, let's hit OK and see what happens. Okay, it looks like we got a few little funny moves at the top. That's probably for avoidance. And then it pulls out. It does look like it is starting at the top and working our way down, so that's what we want. But what direction are we going? Let's go to simulate. Let's see what direction we're cutting. So we're cutting in a clockwise direction, which is conventionally cutting against the surface. So that's not what we want. So we're going to exit the simulation. We're going to go back to our parameters. We're going to edit the toolpath. And it says one way. We're going to change that to the other way. And let's see if that works. And that does not. It's still climb cutting. So, conventionally cutting. So, what we're going to do is we're going to go back to our passes tab. We're still going to have one way, and we're going to check this box that says clockwise. It's not intuitive, but it's one of these things where if the machine is cutting the opposite direction, just check the box and that should reverse its direction. Now we go to simulate. And it's going in a counterclockwise direction, which on an inside circle climb cuts. Okay, we're going to exit simulation. Now we're going to cut this outside. Now we could come in here and come in here with a chamfer mill and cut these flat, but the problem is these fillets here are constant, and we would need a variable fillet there to have the chamfer mill give us the right resultant. So we're going to have to come back and surface machine every single one of those anyway. So what we're going to do is we're going to do a modification of what we did on the inside using a different command, but it works similarly. We're going to use the 3D command called morphed spiral. So what this does is it takes a shape that's not specifically a circle and generates toolpath based off your selections. So we're going to select the morphed spiral command, and we're going to use the same cutter, same settings there. So we just go onto the geometry tab, and we don't want to use silhouette. That's if you're going to do the entire part. And we're going to do selection, and we're going to cut between the top octagon and the bottom octagon of the fillet and chamfer features. Okay, and on the next tab, again, we're going to go to outside of the boundary. So we want the tool to go past the boundary with its full diameter, and we're going to avoid the same surface at the top. That way we don't cut into our flat surface. We're then going to go to heights, and we're going to go from model top on both our heights, the retract and the top height. And our bottom height, we don't want to go to the bottom of the model. We want to go to a selection point. And that selection point is going to be at the tangency of the vertical wall and the fillet. Okay, that's our lower selection, but we want the ball cutter to cut past tangency so we get a nice fillet there. So we're going to put in half the diameter of an 1/8 inch ball, negative 0.0625. Okay. If you wanted to, we could round that up to 3 just for good measure, and it'll cut a little bit deeper. Alright, 3-axis tab, nothing to do. Linking tab, we're just going to get rid of this vertical lead-in radius and the vertical lead-out radius. Now let's hit OK, and hopefully it does what we want. So it marches down the surface. We don't really have material where those corners are showing. That was machined away by a prior operation. So what we should be looking at is a hexagon. It's already cleared around the perimeter, and then this cutter comes down and goes around circles. Now let's make sure we're going in the right direction. And we are not. On the outside contours, we do want to go clockwise, and it's going counterclockwise. Alright, so let's exit the simulation. We're going to go back into that routine. We're going to go to the passes tab, and we're going to check this box that says clockwise. We also forgot to check this one-way direction. We only want to machine in one direction. And the step over should have been 0.005. I did not give you the right information. And we want the smoothing tab checked. Let's hit OK. It's going to take a little longer to process. Alright, you notice our step overs are closer together. And then let's do a simulate to see how it machines. And it's going clockwise like we want. Again, in reality, there's not that much material to remove. Alright, let's make sure we've saved